Okay, so today we're looking at LCD, which is looking at LCM in a slightly different variation. So I'm looking at page 9, number 4, 16a cubed and 56a squared b. 56a squared b. Okay, so we're looking for the LCM of these two numbers. Mr. A, why do you call them numbers? Do you guys remember what a variable actually is? It's a number, right? You just don't know it. So I'm going to treat it like a number, even though I might not know what it is. It's a number. It's just I don't know. Okay, so do you guys remember? Method 1 would be to list out all the factors of multiples of 16a cubed. 16a cubed, 32a cubed, or a to the 6. Man, I'm getting into weird territory here. Which method am I going to use? 2. So what I'm going to do first is get the prime factorization of this expression, and that can start off with just a number. So can someone help me out with 16? Yep. 4 and 4. So 4 times 4 is going to get me 16. But I keep going because neither of those are prime numbers. So 4 breaks down into 2 and 2. So I circle those because those are prime numbers. And 4, again, breaks down to 2 and 2. So I have my factorization right here. Okay, now I'm going to rewrite that factorization. 2 times 2 times 2 times 2. I just rewrote it. But then what do I do with that variable a cubed? Do you guys remember what to do with it?
Times a cubed.
You can say times a cubed or times a times...
Times a times a cubed.
Yeah, and I'm going to draw it out there, but soon you're going to realize, Mr. A, can't you just... And I'll let you do that, but I'm trying to break it down for all of you. Okay, 56a squared b. Ooh, how do I break down 56? Darius? Yeah, what's a math fact that gets me 56?
7 times 8.
7 times 8. So use your math facts to help you out with these problems because, yes, 7 times 8 is 56. 7 is a prime number, but 8 is not. 2 and 4, and then 2 and 2. Okay, so there's my prime factorization of the numerical part of the second expression. So what's the prime factorization of 56a squared b? Can anyone give me the whole thing that I'm going to write here? William?
Sorry.
That's okay.
2 times 2 times 2 times 7 times a times a times b.
Okay, good. That's my prime factorization. All right, I got my two prime factorizations. Okay, everyone, does anyone have a question up to this point? This is review. Okay, now, do you guys remember what I'm looking for next? It's a unique word that I use. It's very unique. So unique. It is, Hudson?
I forget what the word is, but you're trying to find which number they use more of.
Okay, yep. You're going to eventually look at how many times is each unique factor used the most. That's correct. Okay, so what's that word I'm looking for? Unique. So how many unique numbers, let's show you their letters. What are they also known as? Numbers. How many unique factors do I have? Henry?
4.
I have 2, 7, A, and B. You guys agree with that?
Well, so do you do the unique numbers like including both of them or just one?
All, yeah, you're looking at all of these and saying, all right, how many numbers are unique? 4 of them are 2, 7, A, and B. All right, so 2, 7, A, and B are going to be part of the LCM. They have to, at least once each. All right, now this is the part where a lot of people get stuck on, but how many times is 2 used in the first prime factorization? How many times? 4. How many times in the second prime factorization? 3. How many times should I use it then? 4. It's used the most 4 times, so 2 to the 4th. Okay, that's how I got that exponent. All right, 7 is used the most how many times? Darius? Once. And it's only used once overall. A is used the most how many times?
3.
And Grace? 3 in the first factorization. And B is used the most how many times, Hudson? Once on the second factorization. I just put the ones there to emphasize it's used once the most. So you don't have to put it there. All right, what's 2 to the 4th? 16. 7 to the 1st? 7. And then I already know what those are. It's A cubed and B. Okay? What's 16 times 7? 16 times 7, 112. And then what's my final answer? 112.
A to the third.
Good. And notice how we said it different ways. I heard 112a cubed b or 112a to the third b. Both of those are correct. They're just the same variation of the problem. All right, how many of you could have gotten 112a cubed b squared? Oh, excuse me, just b. 112a cubed b. You guys kind of get that process? Okay, any questions on that process up to now? Because now we're going to extend that to fractions and LCD. Did we talk about LCD? No. Okay, it's really not that much different. You're going to hopefully find out there's a huge similarity. Okay, all right. Now, when I get fractions, and let's start off with, you want a tough problem here?
Yeah.
Yeah, let's get a tough problem. Okay, not that tough, but it is going to take some work. Okay, I'm looking at this problem. It's hard to point out, but it's dealing with the fractions negative 2/3, negative 3/4, and negative 4/5, I believe. Let me make sure. Okay. All right, this is the last type of problem you're going to do on your homework, okay? So please pay attention because they'll help you out. Okay, the instructions for this problem would be rename the following fractions using the LCD. Rename the following fractions using the LCD. Okay, I get what renaming is. That means changing these numbers a little bit. The LCD, I have no clue what that is. So someone help me out. Yep, Gracie? Least common denominator. Okay, so I'm going to write that down. LCD. And you're like, yeah, I get least common multiple, but why least common denominator? This is all I'm asking for. Ready? All right. In a fraction, which part is the denominator? The bottom part, you could say, right? So what I'm actually asking for when I want to find the LCD of these three fractions is I'm looking at the denominators, 3, 4, and 5. I want to know what's the LCM of 3, 4, and 5. Could you find the LCM of 3, 4, and 5? Could you find that out? Okay. There are three methods. I'm going to call them three methods. First method, lists out all the factors, right? 3, 6, 9, 12, blah, blah, blah. 4, okay, 5. Or you can do prime factorization like we did on the last problem. Or, what do you notice about these three numbers, 3, 4, and 5? Something special about them. Something not, well, I guess not unique because many numbers have this, but it's a key term I'm looking for. Key term. Oh, the hands fell a little bit. Alex?
Pattern?
Oh, there is a pattern like 3, 4, 5. Yeah, but something about those three numbers as far as their factors. So think of their factors. The factors of 3, the factors of 4, the factors of 5. Hudson?
2 over 3, that would be the next to last, 3 over 4, next to like 4.
Oh, you're looking at the numbers, right? Yeah, there is a pattern.
Like
but
each of them, like
the denominator moved up to the numerator, and then one up on the number. But I'm just looking at these numbers, 3, 4, and 5. They are relatively prime. Do you guys remember that?
Yes.
Okay, relatively prime means this. Does 3, 4, and 5 have any factors in common other than 1? No, there's no other factors common but 1. So you know what the LCM of 3, 4, and 5 is? What's 3 times 4? 12 times 5? 60. It's 60. That's the LCD.
Every time we wanted to find the least common denominator.
No, because...
So you make them relatively prime, then you multiply them together?
No, if they're relatively prime, you can multiply them together. If they're not relatively prime, use another method. Yeah, that's like a shortcut. Yeah, let's go through that method. Prime factorization. What's the prime factorization of 3?
3.
It's just 3. There's nothing to do. Prime factorization of 4? 2 times 2. That's what I'm asking for. What's the prime factorization of 5? 5. Okay, so you notice there's not much to do there. All right, how many unique factors? So just look at these. How many unique factors are there? 3. Do you notice what's going to happen here? Okay, but anyway, 2, 3, and 5. How many times does 2 use the most? Twice. How many times does 3 use the most? Once. How many times does 5 use the most? So you see what just happened? We're just multiplying all 3 of them. That's when they're relatively prime. Do you see any common factors here? Anything common? Nope. Multiply the numbers together. You're done. For the LCD. Yep.
So the LCD is sort of the same as the LCM,
yes.
except it's for the bottom of bracket.
Exactly. It's just talking about this. Just these numbers. You're like, why would we do that? Like, why? Is that just something fun to do? No. It's useful. And here's the use. All right. We are not done with this problem. Any questions on finding the LCM of the denominators? Yep.
So I'm just confused on like the order that you do everything, kind of like how you set it up.
Okay, I would say my first step with fractions, when they ask you for using LCD, when you think LCD, this is what I do. Look at the denominators and get that LCM, like you did on previous problems.
Okay.
That's what we just said. We found it. It's 60. Okay, so what do I do with that? Now what I'm going to do is I'm going to do the second step, which is renaming. So I think Alex knows, but here's what I'm going to do. I'm going to write negative 2/3. I want to rename it so that this denominator is actually 60. Is that even possible to do? Can you rename a fraction to have a different denominator? Okay, but now you're asking, okay, but how do you do that? And I was very picky with the other class. I asked them, what should you multiply 2/3 by to get a denominator of 60? You know what it is? So what should I do to multiply, what should I multiply 3 by to get 60? So you're like, how do you even figure that out? Well, someone maybe can help us out. I'll give you some time to figure that number out. Sometimes you can do it mentally, sometimes you just need to work it out, and that's okay. Okay, what's that number? Michelle? 20. Okay, 20 is the answer. How many of you got 20? Like you thought 20. Okay, but I'm very picky on how you say that, so I'm not going to accept that. It's not 20. It's actually not 20. You're like, what? Alex?
20 over 20.
It's 20 over 20. Mr. A, you're just a picky guy. I am. Because what's 20 worth? 20. What's 20 over 20 worth? 1. Is there a difference between 1 and 20? Yes. So I'm going to multiply this by 20 over 20, okay, which is a big fat 1, which we're going to look at is the identity property. When I multiply any number by 1, I keep the same identity. It's like me. I come, hopefully, every day dressed in different clothes. Am I a different person when I wear a different colored shirt? Different clothes, I'm the same person on the inside. Okay, so you get what I'm saying there? If I get a new haircut, which you're saying maybe you should, but if I get a new haircut, am I a different person? No, I just look different. And it's still me. It's still Mr. A. Okay, what's 2 times 20? 3 times 20. All right, and don't forget, it's still negative. This is one of your answers right here. It's one of your answers. I renamed this fraction so that it has the LCD. Okay, I'll go through it again because that might not be too clear. Second fraction is negative 3/4. I'm going to be very picky with your answer. What should I multiply 3/4 by to get that denominator? Answer wisely, Josiah.
15 over 15.
He said 15 over 15, which is correct. Not 15, because those are not the same value. How do you get 15, though? Either you memorize that fact, like you just know 4 times 15 is 60, but if you don't know, you can do 60 divided by 4, and that gets you your 15, and then that gets you the top number. All right. Yes, ma'am?
Couldn't you just do 3 times 5?
You mean up there? Yeah. Yes. If you know there's a little secret here, use it. I'm good with that. That's how you can use it, especially with more difficult numbers. What's 3 times 15? 3 times 15. And again, if you don't know it off the top of your head, just work it out. 4 times 15?
60.
That's your second fraction. You rename the fraction using the LCD. You guys notice they all have the same denominator now so far? Does this even matter? Like, what, are we just doing fun activity? Oh, this is awesome. Okay, some of you are saying, no, this is not awesome. But we're doing it. Why? Look into your future. Why are you doing this? Why do you do this? Anyone?
You become a math teacher.
Yeah, you could be a math teacher when you are older. No, it's actually going to happen next week. Why do you need this?
For the test.
Okay, that's 2 weeks from now. For next week. That might come next week. Yep. Oh, that is coming next week. Because how do you add, all this stuff. Are you going to have to add or subtract fractions? Do you need a common denominator?
No.
What's the best denominator to use? The LCD. You can get any common multiple. You can use 120, but you're making your math much more difficult. Why make it difficult when you can look at the least common denominator? All right, last one. Who can kind of help me with -4/5? I don't know what to do. I'm all that talking, and I just lost everything. And it's almost lunch, so I'm hungry. And I'm self-conscious about my hair because I made you guys all look at. By the way, guys, like I said, doesn't just happen. Okay, sorry. A lot of product, a lot of patience, and a lot of movement. Okay, Hudson, what do I do? Kind of walk me through this. 12 over 12, okay? Which gives me what? 48 over 60. What else is missing? Negative. You're talking about a negative number, so negative answer. Okay. Yeah, be careful of that. And listen, okay, that's actually a good point. Okay, you said you guarantee you're going to miss a negative. So what should you on every one of these problems be thinking of? Did I put the negative, right? So now you're like, I always forget the negative. I mean, I always do. Did I do it this time? Yes, I did. So change it. Yep, that's okay. I forget negatives too. It happens. Yes, Sam.
The 12 because did you add the 5, 4, and 3 up?
You could have added, you could have multiplied. So to get, what do you multiply 5 by? You do this.
Yeah, just add those together.
Multiply those two together, right? Mm-hmm.
Are we going to add all of them together?
Not yet. We're just getting common denominators. Mm-hmm.
I'm still kind of a little confused.
Okay, I'll give you guys a practice problem, then I'll let you go with your homework. One last problem. It's a toughie. Because it seems like it's not a big number, but you got to think through it. Page 9, where it says try these, and this is the last problem you'll do altogether, number 9. I want you to rename that set of fractions using the LCD, this process. Okay, so go ahead and do number 9 by yourself. And that's okay. I'll walk you through little by little, but I'll be behind you. So I'm giving you time to think. I want you to think. Look at your notes. Look at what we did in the last problem. See if you can figure it out. So the two fractions, 7 over... Oh my, Mr. A, you can't have a letter in the denominator. That's wrong. What's a letter in algebra? It's a number. Are you allowed to have a number in the denominator?
No. Yes.
Yes. Some are like, no, never. Okay, yes. So then that helps me to deal with it. Okay, first step. Find the LCD. Or you could say find the LCM of the denominator. So basically I want to find the LCD. That's like a key part of my problem. What are the denominators? 8a, 15a. Sam?
So, with that was sort of like a problem distances are relatively fine.
Yes. No, they are.
Okay, I was about to say because you can't break the line or into 2, right?
You can break it into 3 and 5, but yeah, do they have any common factors? No, other than 1, no. So they are what you said. Hopefully you heard it. That'll help you out. Or you can do it the long way. It's fine with me. Either way, it's going to work. Either way, it has to work. Can you list out factors for both of these? Of course you can, but you might have to go far. So just be careful. So how many of you are breaking them down prime factorization? How many of you are doing that? Okay. And some of you already realized something else about it. That's fine. Okay. I'm going to do that. I'm going to break this down prime factorization. Did you guys get this?
Yes.
Okay. And then for the second prime factorization, did you guys get this?
Yeah.
Okay, so we're good on that. So we can use this method and then Sam, we're going to confirm it, see if it works. Okay, how many unique factors, Eva? How many unique factors?
4.
4. So we're going to use a 2, a 3, a 5, and an A. At least one of each of those. At least. You got to use one of each. So how many times are we going to use 2, Mary? So how many times is 2 used the most in either one of these? 3 times. Jackson, how many times should I use 3? Once. Jack, how many times should I use 5? Once. Hagen, how many times should I use A?
Twice. Wait, once.
Which one? Final answer.
Once.
Why?
Because you just want it in like
Try to give it to me in words. Try it. It's okay if you don't get it the way I said it. You want to use each variable
like how many times it is in each row?
the most in each row. Yes. How many times do you use here? Once. How many times do you use here? Once. So we're going to use it once. Good. Okay. What is 2 to the third times 3 times 5 times A? Philip?
128.
120. Yeah, and I remember in the last class I was like, 128. What do you say? It's 120A. You guys okay with that? So how could you have found this number out? So I'll put it up here, 120A. How could you have found that number without prime factorization? Like, what if you didn't do this? Could you find it out, Natalie?
You could have done 18 times 8. Or,
What?
and then you add the A.
Yeah, you put the A there. Yep. Okay. Yeah. What's 8 times 15? It's right here. It's 120. So you could have gotten that way. So, guys, if you know relatively prime, does that kind of help you out? Yeah, because it makes your life a little bit easier. Okay, but do you still get it with prime factorization? We like that, yeah. So we're going to use that if we don't know, or we know it's not relatively prime. Yes, sir?
Did you do that, like, multiplying trick with every single one?
The prime factorization?
So, like, 8
No, 8.
No. So what happens is, let's say this number was 16 and 15, for example. Well, that'd still be it. Let's say this were, okay, if you had other numbers, you can multiply them together and you'll get a common denominator, but you won't get the least common denominator, and you just made your life harder. But I want to see least common, so I am going to require that. Okay, all right, everyone okay with how I get the LCM of the denominators?
Yes.
Whew. So, sorry. Oops. No, we're not. That's not the answer. Because what do we have to do in this problem? That's okay. That's right. You have to rename both of these fractions to have that common denominator. So we'll finish this up. This is like your second step. That's a big step, Mr. A. Yep. Yeah. What's kind of funny is like, okay, my son Titus. Did anyone see my little guy at the games?
Yeah.
He was at the volleyball game. Yeah. He's a little tyke, little guy. But he likes going in everywhere. So for him, those stairs that we have in our house, he's like, he lifts up his leg real high to get up there. But he does it. Trust me, he does it. But what about my 3-year-old Ezra? They're still kind of tall, but do you think he has to really stretch out his leg to get up there? No, he just kind of like steps up, kind of like I do. And me, it's kind of just like, just walk up the stairs. Okay, for some of you, this step, number 1 and number 2, they're big steps, like LCM of both the numbers. Okay, but you make it across, and some of you just step over. But you got to go through the 2 steps, right? Whether it's easy, just go up the steps, or whether it's, and he's lifting his leg. He lifts his leg up, and he still makes it across. You will make it. It just might take you long. What should I multiply? 7 over 8a. So that I can get that denominator. Yep.
15 over 15.
Good. 15 over 15. right? Not just 15. And I knew what you meant. I could read Drew's mind, but it's 15 over 15 because 15 over 15 is what? Yeah. So please remember that. What's 7 times 15? Yeah, if you didn't know that, if you're like, Mr. Ed, how'd you get that? You can just do this. I know, old school. Just work it out. What's 8a times 15? 120a. Does this fraction now have that denominator? That's one of my answers. See, that's using the LCD. Mm-hmm.
Okay, so when Hagen found out that it was 15 over 15, did she find it because the other fraction was 15, or she just got it from like dividing?
Either way. I don't know what she did because she didn't tell me. But she could have done it either way, and you could do it either way. Sometimes you know it's the other one, but if you're like, I'm not sure if that's it, just divide that. That'll help out. You can ask her later. Yes?
So the two fractions, you pick the largest denominator out of the two fractions and multiply it by the fraction.
On these examples, yes, but not always. Always get me that LCD, and sometimes it's multiplying by the other number. Sometimes it's multiplying by like a hybrid.
LCD, you pick the largest denominator out of the two and use it and multiply it by.
No, I can't say for that because some problems you don't do that. You have to actually multiply by a smaller number, which is nice. Always just get me that LCD and then see what should I multiply this by to get that LCD. It might have been like you multiply 8 by 2 to get that, and that's okay. So you got to think through it. Hudson? To get the new fraction? The renamed? Yeah. Thank you for asking. All right, what should I multiply 2 over 15a to get that common denominator? Oh. Drew is eager for this. 2 times 8. 15a times 8. That's your second answer. You're done. Okay. I've never heard someone so excited about the homework. That's okay. That's good. All right.
I'm not. Literally, I'm on the first one.
Oh, good point. Okay, anyway, let's go ahead and work this one out. I'm changing your homework because I gave them a little more time, so I'm going to reduce yours. I'll do 2 through 8 even. Actually, you know what? It's going to look better. I don't even have to say that. It's 2 through, so I gave them more problems. You don't get as many. 2 to 32 even. Which seems like it's a lot, but it's fewer problems that they got. This is 7 and 8. Pages 7 and 8. Yeah, okay.
That's it? The class got like 2 through 8, and then they got like something else.
Yeah, like I said, they got more, but I'm giving you less time, so. Okay, with the quiz on Tuesday, if you want to prepare for it, I'm going to make it from lessons 1-1 to 1-4, which is today's lesson. And so we'll see how you do on that. It's a practice. Don't stress out too much. If you want to prep, you may. Please enjoy your weekend.